Hello, work energy chapter bana hi potential energy to conservation of energy involved in potential energy hi to ahe na spring to gravitational potential energy involved in class 12 halekun class 12 ho electrostatics potential energy hom di ja it's question class 12 ata na to ahe so like class 11 work energy chapter ahe. So we'll start with potential energy and then we will do spring potential energy. Okay. Energy bolmasang sat vinna work done chapter work done lecture video kana bolo graph question ho khalani ga bolma sauten about energy potential energy bolyo. So first thing batang work done formula to see work done is given by so integral f dot dr. Okay, if you have a variable force, right? But then graph hi kinematics chapter azong ilole basic azong na basic maths azong graph hi kan say tan. Idia hi if you have any formula integral fx function into dx. Okay, so the meaning of this is if you have a graph of fx versus x graph, dx graph. So here in this graph, if I have a curve like this, okay, so the value of integral fx dx is given by the area under this curve. Sila curve pa na sino area si pen hi cho si. So this is the integral fx dx. Na integration to area tin cho simple ta sa dinga cho. Atila sila hi work done formula cho e hon hi do phem. So integral f into dr. Okay. Atila so that means so in force versus displacement graph, R graph. Okay. So force versus R graph. So the integral, that means the work done. Okay. So the work done, that is W, is given by, what is this? Area under curve. Okay. So simplify the area under the curve, then you'll get the work done, right? So like this, if you have a force versus x and f, okay, so force versus displacement graph like this. So let's suppose, let's say a graph is given like this, okay, value allowed in an example. So till r equals to, let's say 2, okay, so r is meter, and then I comes down here again. Say let's say this is how much 4. F2 10 Newton got 11 na. Force Newton. Atila hi, if I go from A to B to C, what is the work done? Work done is that the Chilai sema pangwachuna F versus R graph achu work done chu pia. So it is given by the area under the curve. Okay. So you find out the area under the curve. So here you have one area and second area. First area, second area. So I can divide this into one triangle here, another triangle here. Okay. So that means I have two triangles, right? So what is the area of the first triangle? So half base into height. Okay, total area will be, how to write? So work done is equals to total area. Okay, so area of AB, and let's say this is D. ABD plus area of what? BCD, na BCD. Okay, so area of ABD is a triangle half into base to 2 into height to 10 plus area of BCD who, so half into 2 into 10 kipang na. Okay, so this is the first triangle. So ABD, so half into base to chihi na chihi 2 is a height to chihi 10. Okay, for the second triangle also this is 2, so the height is also 2. Okay, atila solve lessons at the so half cancel out, half cancel out, so you'll have 20 joules. Okay, so this is the work done. So therefore, if you go from A to B to C, okay, then the total work done will be 20 joules. Okay, just find out the area under this path here. Okay, so we'll do one more question here. Question. Example, force versus displacement graph. Let's say this is -1, this is -2. So 1, 2, 3, and 4. Here 1, 2, 3. Let's say this is 5, 10, 15. Okay, like this. Nilong here minus 5 and then minus 10. Minus 10 So I'm going to draw some random graphs. Suppose A pada B Okay, wait. A to B. Nah, sila B 10 nahi. Abana so B pada let's say let's come down like this here. B pada C, C pada D, D pada E Okay, like this. Okay, and then question 2. Work done, total work done. Okay, work done on going from A to B to C to D to E. So work done from A to B to C to D to E. E apa E work done So you have to find out the area. Okay. Must have been A, B, graph I can take one area here. So I have the next area here. So you have one area here. Abana area dan na. Total them. First, area 1 to 3 nga homo te chila hi. Chipahi area 1, area 2, area chipahi area 3, na bana chu area 4. Area 1 hi is that have value. So area 1. So that means half into base who is that they have base who. Chi base chala na chi 2. Okay, base is 2. So half into 2 into height is that they have 10. Okay. Chipahi height na chipen here. Okay, so and then how much is this? 2 to cancel out, you have 10 joules. Plus 10 joules. Na, abana ko na B to C ko. B apa is 2 na, area 2. So half into base 1 into height 2, 10. So this is how much? 5 joules. 2, 1 is 2, 2, 5 are 10. Abana third area here. Half into base who is that hato triangle bumbola ke tung na jila here. So this is 1. Okay, so the height is 10, right? So half into 1 into height 2 minus 10. Okay. But then work done here negative negative. So therefore I will have here minus 5 joules. Abana ko area 4 na ho. Area 4 na ho half into base ko 2 na into height 2 minus 10. So how much is this? Minus 10 joules. At the total so 10 plus work done total equals to 10 plus 5 minus 10 minus 5 you'll get how much? 0. Okay, so 0 is the total work done. Okay, so like that graph on KP alajun na force versus displacement graph KP alajun work done to area under curve. Okay, so remember that point. So we are just extending some part. Video mas apela na kabol hai mil pa so chala kan repeat so ajila hai. So now let's go into energy. Potential energy. Video mas achu potential energy to kinetic energy bol so na chumchuma energy types of energy bolwa work energy theorem hai bolwa to ahi. So we are going to study potential energy. Okay, potential energy is also gravitation to spring potential energy chumchuma involved. Okay, and then we will jump into conservation of energy. Atile bana hi gravitational potential energy na chupi ham see suppose at surface cho surface ahi block khatum na chala hi block chu mass m divte ale he block pa hi. So if this block is lifted, okay, so to certain height, let's say height h atile block chu chala him da cho mass m. Okay, the he chala hi block pa hi. So on lifting the block from here to here, okay, so some work is done, right? Atile work done by gravity ka atilang na. Suppose what is the work done by gravity? So at any instant, if you see, so mg weight of the block so hilang ha gravitational force la na japan hi mg. So mg is the force of gravity. So this is downward. Okay, the force by downward chola na. Eva displacement so hilang ha displacement chu achung lang chola na x block pa chito cho block pa chung la chito na level chun displacement to conservative force pa hi opposite so opposite hel chun work done chu pi ha negative de na se. Okay, so you might have heard of work done by gravity. So gravitational potential energy is negative. Okay, it's ham tele work done by gravity chui bola negative ham tele force to displacement hi opposite direction amji ana chala hi. So because of that it is negative. Okay, so atile chun block pa hi chalai para hi na chalai para hi up to a height of h chanchu ake tol tawala chun na achi tawala chun displacement to h cho na ale gravitational force pe ha mg downwards cho na atile what will be the work done? So work done by gravity. Okay, work done by gravity chusa de ha. So work done by gravity. So there is force mg into height to h na about let's opposite direction hida to minus. Okay, so this is the work done by gravity minus mgh. Let's suppose value ga pilewa na chala hi atila chu some energy chana energy thapar ma suppose 100 joule bang de atila chalai pa chalai na china chu let's say around 50 joules, negative 50 joules is the work done by gravity. Okay, atila block chalai thona chu what will be the final potential energy? So whatever work is done by the conservative force, this will be stored as potential energy. His statement is last videos also. So work done by conservative conservative force is stored as potential energy. So initially, suppose I take initial energy of the block. Initial energy, let's say some 100 joules. Okay, ale height h china here work done by gravity. So work done by gravity. So let's say there is work done by conservative force, that is let's say minus 50 joules. Okay, and what will be the final potential energy? Is that the so that relation, potential energy relation, if we use here, so U initial minus U final equals to work done by conservative force. Here's the formula here. Last video ka say that. So lana chila here. And value who put lechun initial to 100 is a minus U final equals to minus 50 joules. Okay. So from here 100 plus 50 is equals to U final. Atila U final to piham so 150 joules. Okay. So like kuna cha pivot sana ha. So whatever work you do is now stored as potential energy. Okay. Final potential energy to kalta cho initial to compare lo chun na. Okay. Ati let's like one conclusion to PZ ha. Suppose if a block goes upward, okay, if a block ascend by height h, so then the potential energy will increase by how much? By mgh. Okay. Right? So if a block if a block goes down by height h, so the potential energy is going to decrease by mgh. Mgh should be mgh is the work done by gravity na. Hichala minus 50 ti pa hui pa chepen hi mgh value cho chi. Right? So if a block goes upward by height h, the potential energy is going to increase by this much. Okay, if a block goes upward by a distance of h, then the potential energy is going to increase by how much? By mgh. Okay, and if a block goes down, if a block descends by height h, then the potential energy is going to decrease by mgh. Okay, that is the final conclusion, right? So if a block, if a body, okay, goes up by height h, okay, then potential energy increases, okay, increases by how much? mgh. Okay, this is the work done by gravity. And if a body goes down, similarly, if a body goes down by height h, the potential energy is going to decrease by mgh. Okay, right? Let's next we have spring potential energy. The potential energy ahe ni hi chalai bol deu. So spring to gravitation pa hai na. Electrostatic pa ho class 12 na bol deu ha. Suppose I have a spring system here. So a spring. Okay, if it is not connected to anything, here if I keep it like this, okay, so there is no extension here, right? And then no compression. Okay, extension to compression here na. So spring was son leo chun. So the length of the spring decreases. Okay, so that is compression. Ki compress na. If a string is pulled out and then the length of the string increases, so that is called extension. Okay. Atila hela hita spring khai mo koi fala chun, no extension, no compression. Okay, so this is the natural length. Okay, we call this natural length. Spring pa hi natural length na. So here suppose if I push this, okay, if I push by some force F, then the length of the string decreases, right? So this is compression. Okay, sipai compression ketina. Ale if the spring is pulled, okay, if it is pulled, by some force outward. So this is called extension. Okay. Basic terms related to spring. Okay. Ale spring force kiti ho pe ha. See. Tu hin na chi spring pa he tin son leo chun. What will you feel? You will feel that the spring is pushing you backwards. Okay, opposite direction. Na. Tu hin spring pa he tin lui leo chun. You will feel that the spring is pulling you in this direction. Okay. So there is a restoring force. He pa he restoring force kiti cho. It tries to restore the spring to its natural length. Right? So if I pull, the second case na version, if I compress, okay, if I compress in this direction, so external force is this one, so there will be a force which is trying to restore the string to its natural length. So this is a spring force. Okay, Fs got the na Japan here. It is spring force. It is a restoring force. It opposes the compression or extension. Okay. So it tries to restore the spring to its natural length. Extension if it is pulled, okay, by external force outwards, then the spring force will act opposite to this. So let's say this is spring force Fs. Okay, it is spring force by formula here. So spring force is equals to minus k into x. Okay, so where k is what? K is the spring constant. Okay. Spring constant. Kia tam chana spring cho ham di na cho short ha de na. So x is the extension or compression. Okay, compression or extension. Ye betan chala he bola minus ha because this is a restoring force. Okay, it always acts opposite to the external force. Betan chala he external force chu chilang hisa spring force to opposite na. Hila hi ani na pa hi external force to zilang hisa spring force to veilang na. It is always opposite. Therefore, you have a minus here. Okay, it is a restoring force. So wherever you have a spring, you're going to use this force. Okay, F equals to minus kx. Ala 2 hin spring potential energy view. Suppose I have a spring. Okay, right. So a spring and a block got you there. Spring the block mass spring. So spring constant k. No extension. Now the spring is at a natural length. Okay. Ale let's say initially, okay, at t equals to 0. So the spring was pulled to certain distance. Okay. Natural length is a natural length apara here. Let's say distance x1. Okay, x1 here key extend tacho. Right, so due to some external force. Okay, here. Okay, then let's say at time t equals to at a particular instant. Okay, so this is being pulled to so x2 here. So now it's being pulled to x2. Okay, so some external force is here. Like question to piham. See on time t equals to 0, time t equals to t. Na, initial na. So you have x1 extension. So from x1 extension to x2 extension, pull na. So some work is done, right? Okay, work done by external force, work done by the springs. A level situation situation. So some work is done, right? So whatever work is done will be stored as a spring potential energy. Okay, right? Suppose if initially you have at this point you have some energy as 100, okay, 100 joules. Then so on going from here to here, okay, so let's say some 50 joules is done. Again minus 50. As a displacement to hilang hisa spring force to silang hina. So this is kx. Okay, so this is the displacement. So both of them are opposite direction. Therefore, again you have minus 50. Until the final pass is at the so again you'll have 100 plus 50. So which is 150 joules. Okay, right? So whatever work is done by the spring is now stored as potential energy of the spring. Okay. So at any part at a particular instant, let's say when the spring was pulled from here to here, let's say by distance dx. Okay. Now here's a block by suppose at a particular instant, this block goes from here to here. So a small work done. Okay. So when the block goes from here to here. Okay, like in this direction. Na. Hechika work done pass. So let's say dw, small dw. Okay, small dw. So that is equals to, so spring force F into work done by spring to, so F into dx tivte. Na Japan here. Okay, on displacement dx. Okay, at a particular instantaneous na. Hichipa integrate bolleon. So dw equals to, so integral fx dx. Right? Fx to pita kx into dx. Okay, kx dx na. Let's say spring force restoring force is minus kx. So na, you can put here minus kx here. Okay, and then we are going from x1 to x2. Okay, so now you simply have to integrate this one. So minus comes out. So k comes out. Integration of x2 x squared by 2. Okay, from x1 to x2. To solve lesson so if I put the values, I will have here minus k into, so I will have here x2 squared by 2 minus x1 squared by 2. Okay, so that means I will have here half k x1 squared minus half k x2 squared. Okay, so that is the dw. Work done here. So the work done will be stored as potential energy. Okay, so that means I can write here in place of dw, I can simply write du. Okay, from u initial to u final. Okay, u at x1 to u at 2 x2. Okay, so that means this is what is the du integration to u na, from u1 to u2. So I will have here u2 minus u1. Okay, atile potential energy pa hai na nang derivation ke bol hin. So you have to take a reference point. Okay, so at one point you have to take potential energy as 0. Examples of gravitational potential energy ground level is 0. Okay, assume so at the ground level the height is 0. So therefore at ground level potential energy is assumed to be 0. So here let's say x1 is 0. Okay, so suppose initially this was at the natural length, no extension, no compression. Suppose so suppose x1 is equals to 0. So that means as the block was at the natural length here. Okay, so that means what will you have? So assume that if x1 was 0, then what is u1? So u1 will be 0. Okay, as you see, mean natural length. So here there is no extension compression. We assume that at this point the potential energy is 0. Okay, so this is what we assume. Na? So at x equals to 1, if we assume that potential energy initial is 0, then what is the remaining? So u2 should be equals to minus half into k into x2 square. Or in general, potential energy of a spring, okay, by an extension or compression of x, you will have half into k into x square. Okay, so remember this one. So if the spring is extended by a distance x, then the potential energy is going to increase by half kx square. Okay, or if the spring is compressed by a distance of x, the potential energy is going to increase by half kx square. Like that, right? Minus work done by spring. Okay, so whatever work is done by the spring is added to the potential energy. Okay, spring force to it is opposite to external force, opposite to displacement. So that is why you have a negative value here. Okay, right? Okay, spring potential energy. So remember, gravitational potential energy to mgh. Mgh is spring potential energy to half kx square. Okay. It's like minus 1 don't get confused. Okay, when you do calculations, you will use this one, plus. Okay, minus to people restoring force force of gravity opposite to displacement Okay, so finally you have the graph. Okay, graph of energy versus displacement. Spring suppose ga alu even lang na, so motion so at one point it will be like this. Okay, and then it will come back here, and at one point it will be here, so it will compress here, and then it will go back again. It's a oscillation in so you will do it later on again. But what I want to show you is, so when the block gets to the maximum distance and comes back, okay, Now block with hachi ding din, so it will stop here, it will come here, it will stop here, it will go like this. Ita hi oscillation ta ba amazon azela here. So here at the extreme position, the velocity will be 0. It will comes to rest. Okay, it will come here. So here you'll have the maximum velocity, right? It will go along this side. Here you'll have the v equals to 0 again. The block will comes to rest and it will go back again like that. Okay, maximum velocity to lai chula na, minimum velocity to here. Okay, so that means the kinetic energy will be maximum at the center here. Okay, so the kinetic energy pi so it goes like this. It reaches the maximum at here. As it alai ta here, velocity to maximum chula na chila here velocity to 0. So kinetic energy to minimum. Okay, like this. So this is your potential energy, half kx square. So x is maximum here. Okay, so x is maximum. So half kx square is maximum here. Right, extreme. So this point. Right, so this is the relation and the graph of potential energy and kinetic energy. Okay, and if you add those two, you'll have the potential total mechanical energy here. Okay. Atile banchiu tin chi graph pa hi oscillation phajong la avila in vekiti cha. So we'll see this again. Right, next you have conservation of energy. Utang last video conservation of energy condition chupita. Now conservation of energy condition chupita if no external forces okay, external force no na. So if no external forces x, okay, or so the work done by them, okay, work done by all the external forces is 0. Atile external forces affect image amlo tinacho. Okay, condition one na, and all the internal forces, okay, internal forces are conservative. Okay, are conservative. Then the total mechanical energy will be conserved. Okay, so that means initial energy will be equals to final energy. Okay, energy will be constant in nature, conserved na. Total energy so piha. So potential energy initial plus kinetic energy initial will be equals to potential energy final plus kinetic energy final. Okay, so this is the relation. So this is what we call conservation of energy. Okay, so initial kinetic plus initial potential will be equals to final potential plus final kinetic energy, right? So we are going to use this one, okay, in the in solving questions. Masapena so kinematics suppose, okay, you have a body particle mass m is projected with initial speed u, okay, right? So an object mass m is projected with speed u. Question to be what is the maximum height reached by the object? Okay, this is question so na. When you ball v square minus u square t man vai solve na. So now if you know conservation of energy, you can apply conservation of energy here. Okay. Suppose let's say maximum height reaches h max, right? So then the block will the body will go and reach this point h max, like this. So see, h max ya pa ahi pitita body particle parking na. Now the velocity becomes 0. Okay, v becomes 0. Atila chun hi conservation of energy mangleo chun initial energy equals to final energy. Okay, so that means initial potential energy plus initial kinetic energy equals to final potential energy plus final kinetic energy. Initial as a potential energy is at kasi banga ground level ahi potential energy to 0 kg. Right, gravitational potential energy is 0 here. But potential energy to spring zonguma, electrostatic zonguma, gravitational zongum na. And question sila hi pipeni manyo ha. So there is no spring, so no spring potential energy. So there are no charges, so no electrostatic potential energy. Okay, but there is gravity, right? So gravity achu gravitational potential energy pachu lai manyo cha chalai him. Ale ground level ahi na, ground level ahi potential energy is 0. So that means I have 0 plus initial also velocity nature na. So you have kinetic energy. Okay, so that means half into mu square. So this is equals to finally when it reaches here, it has some height here. Okay, so that is the maximum height. Atila chun mz into h max. Kasi chula mz h kati chuna gravitational potential energy chu. So when you go up by height h, so it increases by mz h. So plus final ako velocity to 0 kita na, particle come to rest, so kinetic energy becomes 0. So you solve this to half mu square should be equals to mg into h max. So mass cancel out. So therefore, what is h max? H max is equals to, so u square divided by 2z. Formula ke bang mo na. So maximum height is given by u square by 2z. Okay. Hijela hi derivation bol dan na. Energy method akan met so as ben hi. So what else? Na tang random question ajong, suppose you have one question like this. Suppose at the height h, right? Height h I have a particle here. Okay. Object had omna jepa hi stone khajong tite. So height h I omtin. So if this object is projected with speed u, okay, it will go up and then come back down again na. Atila chun question, so what is the speed when it hits the ground here? V is at the. So you can solve this using energy method, okay? Initial pass everything. So throughout the whole motion, okay? So the only force acting is what? Gravity, right? So gravity is a conservative force, okay? So which means the work done by conservative force does not depend on the path, okay? It depends only on the initial and the final position. Until initial position to final position in the okay? Right? So if I apply that conservation of energy, U initial, E initial equals to E final, okay? So which means U initial plus K initial equals to U final plus K final. U to potential energy tin cho. Atilahin potential energy at ha. Object to chalai hum jalana ji. So it is at certain height, so it has how much mgh. Okay. Mgh oma plus initial as speed jong na U. So you have half m u square. Okay, so this is equals to final so here ma particle so 2 la chu ta jalana 2 la chu tantin. So now the potential energy becomes 0. But you still have final speed, okay, half mv square. Question p hold it v hold it so na like. So all the m gets cancelled out. So what is the remaining? So multiply both sides by 2. So 2zh plus u square should be equals to v square. So from here, what is v square? So this is u square plus 2zh, okay, or v is equals to root over, okay, like this. Right, so this is your final speed, okay. Conservation of energy ki mandan jana chi hisa. Video question solve the ho, na. So most of all of the questions are based on conservation of energy, okay. Conservation of energy mandan jana. Example khaleni in boldio. So from there we will learn, okay. Atila question solve pan kita na. First question cho. Two springs A and B, spring constant KPR, is stretched by applying forces of equal magnitude. So same force is applied. If the energy stored in A is E, then in B is how much? Spring khat jalayam jo chipa spring A diutin. Khat pa chu spring B na chi. Chipa hi Ka hung ding, chipa hi Kb cho. Okay, so you're given that Ka is equals to 2 times of Kb. So question is, if the energy stored in A, batang hita hum cho chi spring teni hi, hilanga force ki apply na. Chila force ki apply cho. So here, batang hita hi spring khat kanai cho na. So one spring is here. Ima cha ki tu lo na chi. So if I apply force here, F here. So if F goes pulled by X, so this is the extension. Sila hivela jun force kha bosi am chuna side lang khat bosa so kaya la chun. So this is the distance x. Ala tu hin lang khalanga wall pa he na. Wall pa hi lowin force khat to koi bela chun. Chi force pa jong hin. Chi force pa jong hin chilangai force f a kaya la chun. Displacement x ma khat na. So if it creates another extension x, until total extension is at that line 2x ta so jala he. Okay. So ai wanga chu chilanga hi wall of mala chun chilanga chu extension um na si x equals to 0. So only extension is this. Okay. Just extension to x. Na ka sai jo piam to ai spring khali tiam cho. Hilang ko na ka pull ala chun. So due to this force, let's say extension is x. Okay. So if I pull again on this side with another force, so due to this extension is, let's say, x. Okay. So the total extension to that ham, total extension will be 2x. Okay. Chilai question kitong pa na chilai hi. Atila given to be ha spring a pa hi. A pa hi. I'll just try to separate this one. A pa energy to E ki pi na question ako E equals to is at the ha. So half into Ka into extension to 2 times of x a the whole square. Okay. Abana chu E pa hi, let's say E is E2. E2 pi whole dot. So this is equals to half into KB into, so 2 times of XB the whole square. Okay. It's equation number 1. It's equation number 2. Okay. Abana chalahi X to XB relation jong I holongai to chalahi. Butang force is equals to K into X. Chichana chalahi. Atile butang force masapa hi. So what is the force here? Force equals to Ka into Xa. Okay, so this is the force. Ani na so force pair force equals to Kb into Xb. Okay. Question P force then kibang ticho. Okay, so they're applying the force of equal magnitude. So that means if I put this as equation number 3, equation number 4, okay, equation number 3 to equation number 4, left hand side na. So that means right hand side must be equal. So Ka into Xa should be equals to Kb into Xb, right? So from here, it's a relation part of line substitution. So 2 times of Kb into Xa should be equals to Kb into Xb. Okay. KB gets cancelled out. Atila XA to XB relationship ita. So you have 2 times of XA should be equals to XB. Okay. Extension here bolai holo ha. As you have to put here. Okay. So here and here. Right? Atila to here. Equation number 1 to 2 huna. Divide bola so ni ping pot ha. So divide 1 and 2. So I will have here. So E divided by E dash or E2. So this is half into Ka into, so 2 times of Xa the whole square. But 2 times of Xa whole square kela 2x 2x2. So xb chana chala hi equation pa hebela chan. So in place of that I will write here xb square divided by half into Ka in Kb into, so this is xb whole square. Okay, 2 times of xb whole square. Let's say like half cancel out. Ka to kb relationship ita. So 2 times of Ka equals to 2 times of kb na. Hilai Ka hilahi 2 times of kb kasi ito hilahi. So kb gets cancel out. Finally relationship ita. So E divided by E2 should be equals to. So here how much? Hilangan ziyute. So E divided by E2 should be equals to xb square. Okay. So 2 into xb square divided by 2 are 4 into xb square. xb square gets cancelled out. 2 1 is 2 2 are 4. So E2 is equals to 2 times of E. Okay. So answer is 2E. Next question is solved as beham dele spring question na ita spring question ang kito aphalachun. So you always have to consider two things. Okay, first is the force equation. Force equation jo kharong ile ani na so beham ani na so energy equation. So this one half kx square. Okay. So in most of the spring force equation you're going to use this too. Okay. Chite ni hilole chite ni hina. Hilole, so like this question you have to use both of them. Okay. So remember that point. Next question. You're given a block of mass 1 kg, okay, is placed at point A, rough check. If slightly pushed towards the right, it stops at B. So calculate the work done by friction force. But work done by friction force, friction force is conservative. Okay, so conservative. So sometimes we say this as energy loss. Okay, energy loss home. To hebela chun block pa hi tayong ki slide atayong ji phala chun na block pa chalai thona chu ato kho tham ne chun lum thim beta ki slide anung chun na. So because some energy is lost as heat here. Okay, so due to friction na initial energy chu is at so it is at mgh ji chun na block chu ki push down me hi. So mass chu 1 into 10 into height chu 1 meter. So this is 10 joules. Okay. Until final energy so final energy at B. Okay, so let's say instead of this one EA tivde. Sipahi EB. EB ho biha again mgh. So H2 H1 m so mass 1 10 into 0.8. So this is how much 8 joules. Okay. Until ke pada energy so 10 joules is energy so 8 joules. That means some energy is lost, right? So how much energy is lost? Energy lost is at hazalahi. So energy loss as work done by friction. Na chu chu de ha. Chila hi 8 minus 10. So final minus initial. So minus 2 joules. Okay. 2 joules to bang da. So chila minus kiti so loss. Okay. Right? Okay, next you have another question. Block mass M is sliding a smooth horizontal surface with velocity v. It meets the spring fixed at one end, having spring constant k. So find the maximum compression. Again, conservation of energy. Ata atila chu block path chang chu na chi. So it comes like this. It has energy half mv square. Okay. So initially there is no extension here. So a potential energy is 0. Okay. So finally, here's a block by hin spring pass or compress or now when the block comes here, so the spring will get compressed. So here you'll have half kx square. Okay. And the block will comes to rest. So kinetic energy final becomes 0. Okay. Conserve bolation energy. So initial energy equals to final energy. Right? So k initial plus u initial should be equals to k final plus u final. K initial should become half mv square plus initial also hi potential energy to spring na. So here you have to use spring potential energy. Okay. So initially there is no compression extension, so energy is 0. So finally block comes to rest. So V is equals to 0. Kinetic energy is 0. And the final potential energy is half into k into x square. So let's assume that finally block zone spring pass or compress palazon na. So now the block comes to rest. Okay, V equals to 0, and there is some compression x in the spring. That's like when equal to half mv square should be equals to half kx square. Half cancel out. X to that. So x square is equals to mv square divided by k. Okay, or what is x? X equals to v into root over m by k. Okay, so that is your answer. Right, let's solve another next question. Here you're given a small block of mass 100 gram is pressed against the horizontal spring fixed at one end. The spring constant hitai pahi block pahi hitai kison bet cho khotila spring ahi compressor da cho na sort bet na tahi ala tu na sort na first pai la do la so release this one, just release the whole system atila chun pahi block pahi spring and push na, so it will have some velocity here and then it will go here. You see this is a projectile. Okay, na hi spring energy conservation to projectile combination so concept ni na atila chun ama sapenin energy pa mang masala chun spring pa ho ki compress ala chun, so that means initial energy, final energy. Okay, so you compress it, so you'll have half into k into some x square. Okay, some compression is here, so plus kinetic energy is 0. So finally, if you release it, x becomes 0. So potential energy becomes 0. So whatever energy you have, okay. So whatever compression spring energy you have, now it is converted into kinetic energy. So let's say initial speed of u. Okay. So from here, what is u? So half into kx square should be equals to half into m into u square. Now half cancel out. So u is with him. So you will have here x into root over k divided by m. Okay. Chipahi initial speed tacho. Initial speed here valachun. But initial speed here valachun question chun pido ha. Where will it hit the ground? 2 meter ticho. Na jipeni the distance is at the ham ticho. X is equals to formula jo piha ux into t ju na jala hi formula cho projectile cho. Okay, jala hi value ki pi hoi put leo chun u chu jan pot ha. So x compression chu is that compress they have through 5 centimeter tina. So 5 into 10 power minus 2 into root over k chu jan ha, k chu 100. Okay, divided by mass chu 100 gram. So 100 grams chu into 10 power minus 3 kg na hi do na. This is that so 5 into 10 power minus 2. So here 100 gets cancelled out. So I have a root over 10 power 3. Okay, so which is that the 5 by 100 5 into 10 power minus 2 so into 10 cube who 10 hung pododing, so root 10 is still there, so like this. Okay, right, so root 10, so here I will have here root 10. So that means u is what? U is 5 by root 10 meter per second. Okay, equation 1 na atile u ki heda la chun to hi pi ki wada to hi time ki wada na time hi ngai chula atile chun matang. So here it is you have initial u, you will go here atile time ju ti hol juta formula hen leva direct at time. So time is equals to root over 2h by z. T chula formula chuna. So here if you apply that formula, so 2 into height is at height. So 2 meter above the ground kiti chula na 2 into 2 divided by 10. So this is how much 2 root aparang pododing 2 by root 10 second. So this is the time. Okay. At the lesson therefore, finally what is x? The range. R to the R. Okay, what is R? So R will be ux into t. So 5 by root 10 into 2 by root 10. Okay, 5 u into t. So that means 10 divided by root 10 into root 10 to 10. Okay, so this is how much? 1 meter. Okay, so horizontal distance travels 1 meter. So very good question. Combination of energy plus projectile motion. Okay, next question. G-mains question. A particle is released from height 8 s above the surface of the earth. Surface of the earth I mean then. Okay, so at a height s, okay, like this s. So like when a particle ki release na so release. Question to biham at a certain height the kinetic energy is 3 times the potential energy. At certain height it let's say particle to chalai hong na hai, so it has some v. Okay, so let's say at a height of let's say this is x na x apha ko na hi. So it is given that the kinetic energy is 3 times the potential energy. So kinetic energy is equals to 3 times the potential energy. Okay, see in Monday na chalai hi. Atile hun matang conservation of energy bang leo chun na chilai ka hi he chilai ha pa la hi chilai ka hi bang leo chun initial a ko see first part. Okay, initial energy equals to final energy. Initial a ko potential energy jo bia mg into s na particle cho chilai hom chilai initial a cho height cho s hi chun mgs na atile chun chilai hong lo na hi potential energy bia so mg into x distance x na chula na chilai hi. So plus initial kinetic energy is 0 as you release me. So if you release it, initial energy velocity is 0. So when you reach this height x, so you have potential energy is mgx plus it has some velocity half mv square. Okay, so like one happy ha. So mg s minus mgx is equals to half into mv square. Equation number 1. Okay. Na conservation of energy ako na chi mo so adele kon question na pikipita hichipa he. So this one kinetic energy is equals to 3 times of potential energy at this instant. Okay, to echalai pa echalai hi kinetic energy so bia half mv square chala na. So this is equals to 3 times of mgx. Na hichi particular instant na hi chalai particle ma hi potential energy so mgx chala na ji hi height x so here so this value you put it here. So this value you put it here. Question number 2 in 1. So I will have here mgs minus mgx is equals to so 3 times of mg into x. Okay. So therefore you transfer mgx on that side. Mgs is equals to 4 times of mgx. Yeah. So mg gets cancelled out. Until x is equals to s by 4. Okay, so now we have the value of x. Height here da to hi. Question jon pi do ham height do a speed jong do so na chela hi. Okay, so now you put this value here, you can find out v in equation number equation 1. Okay, so I will have here mgs minus mg into x hela to s by 4 kaput alachun. This is half into mv square. So here I will have here 3 by 4 mgs is equals to so half into mv square. So gets cancelled out. So 2 1 is 2, 2 2 are 4. Atile v jo ping pod ham v is equals to so 3gs divided by 2 under root. Okay. Which ben ha 3gs by 2 s by 4. Option C. Okay. Okay, one more question. Question number 7. A ball having kinetic energy is given 60 degree. Matang si projectile question chu chipen hi. Hilahi ball khalom na chilahi ball khalom in 60 degree achu initial velocity kp so chipen hi. Let's say here it says ke kp so ke. So velocity chu u here la na. So initial energy is given as ke. Atila highest point achu. Okay, when it is at the highest point, what will be the energy at the highest point? Tang projectile ball lai was a pita chipen hi u cos theta. Okay, u cos 60. So this is u sin 60. Now, and then we say that only the horizontal component remains the same. Okay, so here also you have u cos 60. Highest point has a u sin 60 y component umlaut acho. Okay, makes highest point acho na. So ati lesson utang initial kinetic energy chu zat ta sahi. Ke initial is half into m into u square chu na chalahi. Lesson ke final. Chalahi kinetic energy final is that ha. So half into m into so u cos 60 the whole square. Okay, so how much is this? Half into m into u square into cos 60 to 1 by 2 chulana. So this is by 4. Okay. So this is what? So this is ke, right? So ke is given in quotient. Okay. So therefore you will have ke divided by 4. Option C. Okay. Right. So last question, one medical exam question. An object falls from a height 10 meter. Okay. So 10 meter. Lahi object khatum na chilahi. Chilakona so falls, it is released. It loses 50% of its kinetic energy. Okay. Hung ki su ding itin ground ahung chu dina chilahi. Let's say so this is ke1. Ahung chu ahi na. Ala chu ahi bitim dile half of kinetic energy loss. Okay, so that means it will rebound again. Aki rebound avang hi kinetic energy hi ke1 by 2 ta cho. As it's 50% loss to half so mang da na si. So that means only half is remaining. ke1 by 2 is remaining. Okay. So half of the initial kinetic energy is remaining. So it will reach certain height. Okay, let's say this is x. We have to find that x. Okay. The first part here, conservation of energy mang E initial equals to E final. Right? So you have mgx. Okay, mg into x to be 10 meter. Okay. So this is equals to hung kisulin tool so kinetic energy to ke1 na. So this is the first part. About the second part too, again E final equals to E initial equals to E final mang leochun. So initially you have kinetic energy, so that is ke1 by 2. So potential energy is 0 na initial. So finally you have potential energy mg into x. So this is equation number 2. Okay. Balls rebound ke dingtin chilai to nahi, it becomes a race. Okay. You have potential energy and no kinetic energy. Atile chun equal ball chun chilai ten hi 1 to 2 hu. So what will you have? So here in place of ke, okay, so you put this value here. So mg by 10 you put it here in place of ke. So mg into 10 by 2 should be equals to mg into x. Cancel out. So 2 1 is 2, 2 5 are 10. So x is equals to 5 meter. Okay, so that is the answer. Okay, conservation of energy mandan na question tempat solve identin. Sukile gravitation to spring potential energy introduction in bolo jana jalahi. Okay, so I think that much is enough. Workdone graph tempat bolo jana jalahi. So next video palakun power ball do. So power to whatever is remaining in work power energy, right? Okay, I will stop here. I hope you understand. So see you in the next video. Thank you.